So you see, this is the unit 3, lesson number 1, and it is about properties of exponents, the continuation of algebra 1. So how to use integer exponents, and I can evaluate expression with integer exponents. So I will go straight away to solve practice problem, the first problem here. So find the value of each variable that makes the equation and is true. So the first one is, when do you think the left will be equal to the right? If you see, the left side is 2 raised to 5 and 2 raised to 3 and then 2 raised to 8. So what should be this a? What should be this exponent here? What goes right here? And you can see this basically means it is 2 times 2 times. So 2 is multiplied itself 5 times, and this is 2 is multiplied itself 3 times. So and clearly you can see all together 1, 2, 3, 4, 5, 6, 7, 8. That means this whole thing, it becomes 2 raised to 8. But how do you get it? You're just adding the exponent. So that's all you do. 5 plus 3, which is 2 raised to 8. So this a is same as 8. So therefore a is 8. So all you do is, if you, the laws of exponent says, if you have one product of power, that means this is same as m plus n. You combine these two. But look at the second one. What should be the bottom? 7 raised to 4. So you to get minus 2. So the second formula, if you have a raised to m and a raised to n, this is a raised to m minus n. So if there is a quotient, that means the division of power, then all you do is you subtract the exponents. That means this case, 7 over 4 divided by 7 over b, basically it means 7 raised to 4 minus b. And the right side is already given to you. So the right side is, so let me write this, is given to us as 7 raised to minus 2. That means, so in order that both exponents, this exponent has to be same, see, because it's 7 raised to, and this also is 7 raised to. So all you do is, 4 minus b is minus 2, and you solve for b. So this way you get b, negative b become negative 6, and dividing negative 1, you get 6. So b is equal to 6. And that's the only way you can get minus 2. Even though the common sense is very clear that to get 7, this minus 2, this b has to be 6, because 4 minus 6 only will give you minus 2. But it's better to write all the steps to really understand how it works. And the third question is, what 8 raised to the power c? So 8 raised to the power c, and the 64 you can write as 8 squared. And then we can use the negative exponent property, that is a raised to minus m is same as 1 over a raised to m. This is also same as, if you have a raised to minus p is same as a raised to plus p. So we will use this part, a raised to m. So here this could be written as, this is positive 2, so we can write it a raised to minus 2. So that way, this and this, if you compare, they have the same basis, so the c becomes equal to minus 2. So this is how we solved it. Problem number 3. Let's do the next question. So select all the exponent expressions. So 7 raised to, so which are the correct answer? The first thing is, so there are 3 powers multiplied here. So remember, if it is a raised to m times a raised to n is a raised to m plus n. And even if I had to multiply a raised to m times a raised to n times a raised to p, we can extend this formula and write down a only once and put them together like this. So in this case, we can write this as 7 raised to, so the minus 2 plus 5. So we are adding this and plus minus 3. See? So this will become 7 raised to This and this will together will be minus 5 and plus 5. But minus 5 and plus 5 will be 7 raised to 0, and 7 raised to 0 is 1. Remember the formula: a raised to anything raised to the power 0 is always 1. So this is how we select the answer there. This is the answer, but the process has to be shown, the work has to be shown. How did you get this? So which of this expression is equal to this one, right? So 3 raised to 8 and 3 squared. Remember this is of the form a raised to m and a raised to n. It is same as m minus n. So this we have to write 3 only once, and then 8 minus 2, which is 3 raised to 6. So the answer becomes 3 raised to 6 is the correct answer, and you're done. So this one is saying find the value of each variable that makes the equation true. So 5 raised to 6 divided by 5 raised to m. And it has to be equal to 5 raised to 9. So how do we do this? So you can use the same quotient of power. That means you write 5, 6 minus m equals 5 raised to 9. So that means this two has to be equals 9, and then you subtract 6. So that way you get minus m equals 3, and then divide by minus 1, because there is when you write minus m is same as writing minus 1 times m, and this becomes, and you get the answer. That's how you have to figure out the first one. The second one is a little confusing, but look at this 4m, the right side is 2 raised to 11. So 4 can be written as 4. First of all, what is 4 raised to n? 4 raised to n is, we can always write it as this way. See, this 4, but 4 is same as 2, 2 raised to the power 2. And this is, you can use power of power. That means if there is a 2 exponents, you just have to multiply the 2. So that means this becomes equal to, and this 2 and n will multiply to get 2 raised to n. So I'm going to replace this 4 raised to n right here. So we get 2 raised to 3 is what you have first, and the second one is 2 raised to 2n like this, and that is 2 raised to 11. And then you use the formula product of power. The left side will be 2 raised to 3 plus 2n, and the right side is this. So now both have the same base, so the exponent has to be equal. And then this time you subtract 3, and so we get 8 and divide by 2, you get 4. And you're done. And the last one is C. You have to use the power of power. That means 7 raised to 4 times k, and the right side is 8. So now both the left and the right have the same exponents. I'll just cross this out, and what are you left is 4k is minus 8, and divide by 4, and get k equals minus 2, and you're done. Question number 5 says this one is 6, 6, 6, right? So you can clearly see the answer has to be 1. So this is 1, this is 1, this is 1. The whole thing is, how does this expression helps you like this? Why 6 raised to 0 can be done? Remember, we can use this a raised to m over a raised to n as a raised to m minus n. So we can write this as 6 raised to 3 minus 3, and 6 minus, and we know this answer is 1, but this, applying this formula to this expression where m is 3 and n also is 3. So that's why we can write 3 minus 3, and 3 minus 3 is 0. But this answer is 1, so we say, okay, this also is 1, and we are done. Lesson number 2 is about square roots and the cube root. So let's think about square and cube roots. I can calculate square and cube root. So let me go directly to first problem of practice problem here. So, okay, so first problem is Rewrite the following expression as a number with no exponent. So no more exponents here. Explain or show how you're reasoning. So you're given an expression. So there should not be any exponents. So what can we do here is you can use a raised to m. This formula we can use because they have the same 7 base, and you subtract the exponent. So this becomes 7 raised to minus 3 and minus 5. So these two things has to be subtracted. So I'm going to use the color to show that this is how it is. And then 7 raised to minus 3 stays the same, and 2 negative makes it positive. So it's positive 5. And this becomes 7 raised to 2. And 7 times, this is 7 times 7, and we get 49. So writing all the steps together. So there is no more exponents here. So question number 2 says find the value of each variable that makes the equation true. So the first one is you can use a raised to m raised to n is a raised to m times n. So the m that you see here is, so this can be written as 2 raised to d is multiplied to the 4, that is equal to 2 raised to 12. So now both bases are the same. So if the bases are the same, so that's therefore the exponent has to be the same. And now we can divide by 4. So you get this d goes away. I mean the 4 crosses out and you get d equals 3 and you're done. The b is given 3 raised to 5 and there is 7 raised to 5. And there is, if you see in this case, in this example, 3 raised to 5, let me write that 3 raised to 5 times 7 raised to 5 equals e raised to 5. Now the left side we can use 3 times 7 and then raised to 5 only once becomes e raised to 5. So what property that we use here is if you have a raised to m times and there is b raised to m. So both, when you have the same exponent, we can write this as a times b only one, I mean a times b and then m. So this is the formula to be used here. So I use a is the 3, b is 7, and the m is 5. So the exponent is written only once. So this becomes 21 raised to 5, and this is e raised to 5. So when the exponents are the same, so this is same. So that means the base also have to be the same. So e has to be 21, and you're done. In this example, I'll use this 5 raised to 0 is already 1, so it's like just 1. Then 5 raised to f equals 5 raised to 4. So this is 5 raised to f equals 5 raised to 4. And both the bases are same. So this 5 and this 5 is the same. So the exponent has to be same. F has to be equal to 4 and you're done. So problem 3 says a square has area 9. So that means if this is a square, the area is 9. See, so this is how it is. You can see there are a 3 here and a 3 there. How long is that? So the question is asked, how do we figure out this one? So how do we find this? So that means we can use, so if this is 3 and this is 3, remember this is 90 and this is 45 and this is 45. So this has to be e square root of 2. So we always multiply square root of 2 times the side. So that means here it is square root of 2 times 3, and that is same as 3 times square root of 2. So the square root of 2 is 1.41. So I'm just multiplying 3 times 1.41. So if we multiply by 3, 4 point. The question was asked only how to find the side. So the side, this is the side, but I even try to show you how do you find the diagonal. Suppose you want to find the diagonal this, then the answer will be 4.23. So this is how, even though they did not ask you to find the diagonal, but still, how long are each side? So the answer is A, but I did also find out the diagonal. So hope that helps. to understand that the square root, how did this square root 2 comes from, is also like Pythagorean theorem we can use. What is that Pythagorean theorem? Is if the sides are 3, 3, so if this is 3 and this is 3, and you want to know this, it's like a square plus b square equals c square. So this 3 square plus 3 square is c square. So this becomes 9 plus 9, and that is 2 times 9. There are two nines, which is c square, and then you put a square root both sides. So that for this square root and the square goes away and you get 6, which is square root of 2 times square root of 9, and that is 3 times square root of 2, because this is, and that's how that always you multiply the, so always remember the hypotenuse is square root of 2 times the length. So this is like a formula to be remembered. If it is a 45-45 triangle, so hypotenuse is square root of 2 times the length. Question number 4 shows that the table shows the side length and the area of several squares. That means that maybe this one, maybe this one, maybe this one, and they're asking us a different question. So if the side length is 5, so this means if this is 5 and this is 5, what is the area? So the area is 5 times 5 squared. 5 times 5 is 25. So this becomes 25. This, here the area is given 49. So what squares to give 49? So and you can clearly see it has to be 7. So this has to be 7. In this case, this is side is given as square root of, let's say, 63, square root of 63. So that means the area becomes square root of 63 times square root of 63, which is 63, because so this is same as writing 63, and the answer is 63. So just remember that if we have a square root, then the area is just a 3. That means if this is 98, this has to be square root of 98. So all you do is, if you go backwards, you just put a square root. But if you go this way, you just have to square and write 125, because square root of 125, if you square, is 125. So that's the basic idea, is what's the area. So area is square of the side. So the formula is the area of the square is square of the side. But if the question is asked to find the side, it is the square of the area. So this is all you're supposed to know. Find the two whole numbers that are close to square root of 42. Remember, 42 is between, I can uh, figure out two numbers, perfect squares. So which are the perfect squares? So the perfect squares are 1, 4, 9, 16, 25, 36, 49. And you can see between 42 is between these two is 42 is between 49 and 36. That means if you take square root for all of them, so the order remains the same, and square root of 36 is 6, and this stays 42, and this is 7. So the closest to the is the value of square root of 42, the closer is between 6 and 7. And you can see, so the main thing is between the two whole numbers. So, and since the question is asked, find the two whole numbers, and the two whole numbers are 6 and 7. That's all it is. So the square root of the values, the value of 42, square root of 42 is between the two whole numbers 6 and 7. That's all it is they're asking. So with this, I have finished practice problems. Uh, Lesson number 1 and 2, and the next one I'm going to do 3 and 4. So hopefully we'll try to understand. So the next lesson is about cube root. It means square root of a times square root of a is a, or square root of a the whole square is a. So this is what we learned. The next lesson will be about cube root of a times cube root of a times cube root of a is a. So we will see in the next video.